So now we're moving into the tool inventory, and I'll turn it back over to Lauren and Sierra.
Perfect. So I'm just going to begin with a quick overview of some of the most simple, user-friendly, interactive tools that we have found out of our collection of over 75 tools, as Emily said. And this will be available later for closer look. And I've also have the provided web links if anyone would like to take a look themselves. Next slide, please. All right, we'll begin with the Carp tool. The Carp tool, also known as the Carbon Reduction Potential tool, is an interactive tool that allows users to quickly visualize and quantify net greenhouse gas and emission reductions resulting from the implementation of cropland and grazing land management practices. The user can quantify the current use and impact of key regenerative practices and then estimate the potential to sequester more carbon if these practices are applied more broadly, given the specific farmland resources in a state or region. The tool layers cropland and grazing land acres data from the 2017 Census of Agriculture. Next, please. The tool provides a mechanism to quickly compare practices, their estimated costs, and where the greatest impact can be achieved across a state or region. The tool's data and maps help policymakers and land managers prioritize efforts for cost-effective, optimal climate benefits from agricultural management. This tool is designed to provide high-level estimates for a county or state that can be used to generate maps and data to inform and prioritize conservation planning and practice implementation. Next, please. Moving on to the Carbon Benefits Project tool. This tool is used to estimate the impact of agriculture, forestry, and other land use activities on carbon stock exchanges and greenhouse gas emissions. The Carbon Benefits Projects Consortium has developed scientifically rigorous, cost-effective tools to establish the net carbon benefits of sustainable land management interventions in terms of protected or enhanced carbon stocks and reduced greenhouse gas emissions. Next, please. Within the modeling component, global soil information is provided for carbon stock assessment across the range of world climate zones, soil types, and land use. The resulting data can be used for a national scale with level inventory assessments with the Carbon Benefit Projects tool simple assessment option in data poor regions. However, the associated uncertainties can be large. Next tool, please. Like the other tools, the Cool Farm tool quantifies on-farm greenhouse gas emissions and soil carbon sequestration. It can also be used to show how management decisions impact carbon storage. It is the highest ranking tool currently available in the public domain. Next, please. This tool takes into account that each farm and field responds differently to land management practices. The Cool Farm tool allows farmers to find out how their fields respond to the management options of interest. Farmers manage for cost, productivity, and soil health. And the Cool Farm tool can help model how reduced tillage and adding cover crops can reduce and offset problem emissions while building soil health. This tool has an interactive interface designed for simplicity. It's quick to use and helps stimulate thinking about land management practices by showing hot spots and helping develop action plans. Next slide, please. And finally, the Comet Planner tool, also known as the Carbon Management Evaluation tool, is our chosen tool of choice. Other tools like the Carbon Reduction Potential tool and the Carbon Benefits Project scale their emission reduction coefficients based on this Comet Planner tool. Emission reduction coefficients were derived using a sample-based approach and model runs within Comet. It utilizes USDA greenhouse gas inventory methods. Coefficients were generalized by multi-county regions defined by USDA major land resource areas. Emission estimates represent field emissions only, including those associated with soil and woody biomass, and excluding those from transportation, manufacturing, or processing. Next, please. This online management tool uses the Century Soil Carbon Model to provide a simple and reliable method for estimating changes in carbon sequestration, fuel, and fertilizer use resulting from changes in land management. The tool is designed to evaluate the potential carbon sequestration and greenhouse gas reductions from adopting natural resource conservation services conservation practices. This tool is designed to provide a generalized estimate of the greenhouse gas impacts and conservation practices for the initial planning purposes. The NRCS conservation practices included in Comet Planner are only those that have been identified as having greenhouse gas mitigation and/or carbon sequestration benefits on farms and ranches. This list of conservation practices is based on the qualitative greenhouse benefit rankings of practices prepared by NRCS. Some of the land management practices in the Comet Planner 2 tool include conservation crop rotation, nutrient management, cover crops, prescribed grazing, and range planting. So in summary, all of these tools are trying to estimate greenhouse gas emission and carbon sequestration, but we believe Comet Planner to be the most useful, user-friendly, and helpful. And I'm going to have Lauren take on her side of the presentation with an example of how you can use Comet Planner on your own land. Thank you.
Welcome to Comet Planner. I'm going to give a really brief overview of how to use Comet Planner at home. So if you go to comet-planner.com, you'll be taken to this web page here. So the Comet Planning tool allows users to explore potential atmospheric benefits through enhancing carbon sequestration in soils or biomass and reducing greenhouse gas emissions. The tool provides generalized estimates of greenhouse gas benefits of implementing NRCS conservation practice standards, which users may incorporate into conservation practice planning. So the tool has 4 steps that you need to complete before you can print out a report. So let's start with step 1. So in step 1, you need to name your project, select your state and your county. So let's name this test project. We'll select our state. Today we're talking about New Mexico. So let's select New Mexico, and then we can select a county. So for you, you would select your county of choice, and I'm going to select Union County as mine. So this is my theoretical ranch or farm that I want to look at. So here we go. So once we have step 1, we can move on to step 2. Now, step 2 is where you select the class of conservation practices that best describes the practice you would like to evaluate. So we have all these different categories here. We have cropland management, grazing lands, woody plantings, cropland herbaceous cover, and then restoration of disturbed lands. And when you click on each of these classes, you see these conservation practice standards change below, depending on what category we're looking at. So let's go back to cropland management. Let's select cropland management. And then here we can go down to step 3, where we select an NRCS conservation practice standard and a practice implementation that best describes your system. And we can add as many practices as we like. We can also add a practice under a different class of practices, and we can do that by returning to step 2. So first, let's select something under cropland management. And I think what I'm going to do is I'm going to add a cover crop. I think that sounds like a good idea to me. And when I select on that, we have conservation practice implementations that come up. And what I'm going to do is I'm going to choose this first one, add legume seasonal cover crop to irrigated cropland. And when we add that, you see that positive turns into a negative sign. And that means that I've selected this implementation. And when I've selected that, that also means that it's down here in step 4, right here. So now this says we can also add something from a different class. So that's what I'm going to do. So we're also going to go back to grazing lands. And then I'm going to choose range planting and then seeding forages to improve rangeland condition. Okay, so now that I have the 2 conservation practice standards that I want to implement, I can go down to step 4. So this is where we enter the acreage associated with each conservation practice we selected. So just for the sake of this example, I'm going to choose 100 acres for each. And you can see as I add the acres to our area, we have these numbers change here. And we have all of the relevant greenhouse gases, including carbon dioxide, nitrous oxide, and methane. And then we have them totaling to CO2 equivalents. And we also have the totals below, which include all of our conservation practices that we included. Now, what's very interesting to note too is that negative values indicate a loss of carbon or increased emissions of greenhouse gases, while positive values are indicating a carbon sequestration or reduction of emissions. And you can also, so once you have this information, you can download your results here, which is saved to my computer in a PDF file here. And we can go back. If you scroll down below, this information here shows how all of this information was calculated. You can also click here to show more detailed information on how this was calculated. And we can also, if we scroll back up, we can also select each of these conservation practices to learn more. By doing that, we can either see more about this conservation practice standard, which brings up this great information. And if we go back, we can also look at a one-page summary on how the modeling was done. And then we can get out of that. And there's your final report. So this was just a brief overview of what Comet Planner looks like and how it might work for you on your farm or ranch, and how it might help, especially in the initial stages of planning. And if you're interested in more specific information and more detailed information, I would suggest checking out Comet Farm. So that's Comet, F-A-R-M, Comet Farm. But thanks for listening.
So now we're going to transition into an overview of conservation programs, a bit of history, and a bit about uncertainty in models, and the century model that's underpinning some of these estimates to really inform our discussions going forward. So Joel Brown is the National Ecological Sites team leader with NRCS. He's also a rangeland ecologist with NRCS, located at the Jornada Experimental Range in New Mexico in Las Cruces. And he's the co-leader for the USDA Southwest Climate Hub. He was instrumental in developing guidelines for carbon contracts in rangelands, and in his critique regarding the role of rangeland management and carbon sequestration. So we're really lucky to have Joel here to inform some of this conversation. Joel?
Thank you, Emily. And thank you for the invitation to discuss some of this work. I want to start this morning kind of picking up where the three previous presentations left off. Lauren and Sierra did a really nice job of going over some of the basics and looking at those tools. And one thing that always gets factored into those tools, they are computer models, mathematical models. One of the things that gets factored into those is uncertainty. And this is a really important aspect of using models to predict anything, is the uncertainty associated with that estimate or prediction. And if you're not really familiar with uncertainty in a mathematical sense, think of it as risk. This is the risk that what you predict is really going to happens. So this is an example from a paper that we did a few years ago on uncertainty associated with the model outputs. Now, when we talk about uncertainty, make sure you ask questions and discern if someone's presenting. There's the uncertainty associated with the measurement. That's the kind of the standard research approach. We go to the field, we dig a bunch of holes, we take the samples, and there's always variability. And that's a form of uncertainty. So there's an uncertainty associated with the measurement, or if we come back again and later and do it in a different time, there's uncertainty associated with that. That's the variability that actually exists out there in that commodity that we're trying to measure, or that attribute that we're trying to measure, and how well does our sampling scheme pick that up. But I want to set that aside for a minute. That's kind of the standard approach to uncertainty. But when we're using models to predict things, there's another form of uncertainty, modeling uncertainty, which is generally associated with how well the model that we've chosen to use is parameterized, or how well it's developed for what we want to predict. And here's two very good examples of uncertainty from a model output that we did in this Southwest project a couple of years ago. That top figure there is the distribution of uncertainty that we used with that we came up with the Century model to estimate carbon sequestration. And in the top figure, it's based on reducing stocking rate. So we know a lot about reducing stocking rate. It's a pretty linear relationship. When you reduce stocking rate, you reduce the number of animals that are out there, you reduce the amount that those animals consume, the amount of forage that they consume, so you actually leave more carbon on the ground. That's a pretty straightforward mathematical relationship, and we've got a lot of data on that in this part of the world. So our estimates on that are in the mostly colored brown there, and that's 21 to 40% uncertainty, which or even lower than that in some areas. So that's a pretty good estimate of uncertainty. Anything that you do with biology or ecology is generally going to, if you get less than 20%, you're doing very well. Most of the time it's going to be around 20 to 30%. That's kind of a standard for, something that is ecological in nature or management in nature. So we do a pretty good job in that model that we use, the Century model, which is the basis for Comet farm planner and Comet estimation tools. So if we want to predict the effect of reducing stocking rate on carbon, soil carbon, we can say our model is pretty good. The information that we put into that model matches the information that we use to parameterize it, or we use to develop those equations. Now, on the other hand, that figure below there is the uncertainty associated with replanting or adding legumes to rangeland. And as you might guess, in this part of the world, it's pretty dry. We don't have a lot of information. We don't have a lot of information that we've measured in the field about the effects of reseeding and adding legumes when we replant. So therefore, a lot of it turns red. At best, we get that very high uncertainty of 80 to 100% uncertainty. And that red unknown means that estimate is really unreliable. So that kind of gives you an idea that, you know, if we try to build a program around managing stocking rates, we're pretty confident in what will happen. If we try to build a program around reseeding and adding legumes into rangelands, we're not very confident in what's going to happen based on the field results that we have and the computer models that we've developed. So that kind of gives you an idea of the importance of uncertainty. And when I say uncertainty is a measure of risk, when we go into a market situation, most markets are very interested in two things. One is the amount. How much carbon are we going to sequester? How much greenhouse gas emissions are we going to reduce? But they're also very interested in that uncertainty. And that typically, that uncertainty is what the markets use to develop a discount rate. So if we've got a high number for carbon sequestration, but we've got high uncertainty with it, then we're very likely to have a high discount rate, which is going to lower the price. I'll talk a little bit more about that later as we go through. Okay, that's uncertainty.